In this clip, a monochromatic structure expands into a glowing network. This represents the shift from static markup to functional programming. While HTML defines the content, JavaScript provides the logic required for a page to respond to user input. In this tutorial, we will build 3 specific features to achieve that interactivity. First, we will update text on the page in real time. Second, we will construct an interactive slide-out hamburger menu. And third, we will fetch a live list of data from an external server and display it. Before we start typing, you need 3 things: a code editor, a modern web browser, and a basic understanding of HTML and CSS. Connecting JavaScript directly to your HTML markup is the bridge. Once you cross it, you move from designing web pages to engineering web applications. Step 1 is linking our script. We must place our HTML script tag at the very bottom of the body section. This guarantees the browser loads all your visible elements before the JavaScript tries to interact with them. Our first goal is to update a text block within the DOM. The DOM, or Document Object Model, is the tree-like structure the browser uses to represent your HTML elements. When trying to change that text, many beginners make a common error. They grab the element's text content, save it to an independent variable, and then try to update that new variable instead of the element itself. This diagram shows exactly why that fails. On the left, data flows into an isolated variable container, updating local memory but detaching from the screen. Because text content acts as a getter and setter, you must flow data directly into the DOM node to change the screen. To execute this correctly, you target the exact element ID on the page. Then you assign your new string directly to its text content property. Treating the web page as a live interface, rather than a collection of static variables, is the only reliable way to manipulate what the user sees. Next, we will build an interactive, clickable slide-out hamburger menu. We start by wrapping our code inside a DOM content listener event listener. An event listener is a function that waits for a specific action to occur before running its code. This ensures the script only fires after the HTML is completely loaded and ready. Inside that safety wrapper, we set up a second event listener. We target the specific ID of our hamburger button and instruct JavaScript to listen for a click. When that click happens, we trigger classlist.toggle. This execution adds an active CSS class to the menu element if it is missing, or removes it if it is already there. This flowchart illustrates why this separation of concerns is so efficient. The cursor click triggers a binary JavaScript switch, open or closed. That switch then allows the browser to run the CSS animation block. JavaScript manages the state, while CSS handles the actual sliding motion. The most performant web applications use JavaScript to orchestrate these state changes, leaving the heavy visual lifting to the CSS engine. For our final objective, we will transform an empty unordered list by fetching live author data from an external API. An API, or Application Programming Interface, is a set of rules that lets different software systems communicate and share data. We initiate this with a fetch GET request. By passing the API URL into the fetch function, we retrieve the data. We then chain .then methods to capture the response and parse it into JSON. JSON is a lightweight format for storing and transporting data that JavaScript can easily read. Once we have that JSON data, there is a performance risk to avoid. Appending each fetched item directly to the live DOM one by one forces the browser into expensive, repetitive redraws. This diagram shows the solution. We create a document fragment as an invisible staging area. It collects incoming data off-screen, keeping the live DOM undisturbed. Inside, we map the JSON data, dynamically generating new list items. Finally, the populated fragment appends into the live list in one synchronized high-speed operation. Mastering the Fetch API and batch rendering your elements shifts your web page from a static document into a scalable, data-driven pipeline. You have successfully bridged the gap between writing static markup and engineering a dynamic web application. You achieved 3 core competencies: direct DOM manipulation, event-driven state toggling, and asynchronous external data rendering. To continue your momentum, your next steps involve building post requests to send data back to servers, and utilizing HTML data attributes for local state storage. JavaScript provides the logic layer for the modern web. Mastering these foundational integrations enables the creation of complex, reactive user interfaces.